Okay, so we are going to wrap up this section with system of equations. And again, we're going to go back and spend a lot of time on system of equations. We're not done with it just because we're wrapping up and moving on. We're going to spend a lot more time on this because really it is the bulk of what we're doing this semester. But what we're going to talk about today is when system of equations have special answers. So think back to when we were solving equations and we had two kind of weird situations that happen sometimes when you would get either like 5 equals 5 or like 3 equals 2. Does anybody remember what those two weird situations were? What were our answers? When we got something like 5 equals 5, what do you put? All reals. What if you get something like 3 equals 2? No solution. What does it mean to say no solution?
No matter what.
Guillermo? Exactly. No numbers will work. If you plug in a number, there will never be a number that will work. What does it mean to say all reals?
No matter what function or number you put in, it'll always equal.
Exactly. No matter what number you put in, it will work every single time. So no solution means there's no answer that will work. All reals means every answer will work. And we talked a little bit about when we talked about graphing. What does that look like when you graph a system of equations? Again, when we graph a system, we graph two lines, right? If there's an answer, what does your picture look like? What do your lines do?
Like
They intersect. They cross. At how many spots? Just one, right? So I'm making an X with my hands. They cross where my two arms touch each other. That's an intersection point. That's when you have one answer. That's what most of these are. They cross at one point. What does it look like if there's no solution? What do your lines look like? They're parallel. They never touch each other, right? They never touch each other. What would it look like if it was all reals? They'd be right on top of each other. They're exactly the same line. So what we're going to talk about today is how to find that without graphing. Because again, sometimes people don't want to graph to solve systems of equations. Why not? Why might you not want to graph? Sometimes it takes a while. Yeah? If you don't have a coordinate plane, what do you have to do? You have to make one. That can take a while. If it's big numbers, putting it on a coordinate plane can be annoying. And then, being honest with ourselves, how many times do we forget exactly how to graph a line? Sometimes you might forget, right? If it's not in y equals mx plus b format, you have to change it. There's a whole lot of work. That's why we talked about substitution, and that's why we talked about elimination. Again, elimination, I think, tends to be the way that most people ultimately want to solve systems of equations because I think it tends to be the easiest way. Saying that, none of it's easy, right? All of this is hard. You guys just did 2 problems, but it took us almost 20 minutes, right? So 2 of these problems take a long time. That means none of them are really easy. This just is probably the easiest way. Okay, so let's take a look then at this special system of equations. When we did these equations to begin with, this is just one equation, 2x plus 19 equals 2x plus 17. And then what happened here when we canceled out the 2x's? You got no solution because does 19 equal 17? No, 19 does not equal 17, so you can't have that as an answer to a question. All right, so in a system of equations, there are also times when we'll have a result of no solution. So for instance, let's take a look at this system. So this system is y equals x minus 1. And negative x plus y equals 2. Okay, how do you guys want to solve it? Graphing, substitution, or elimination? Elimination? Okay, if we're going to solve it by elimination, that means what do I need to do? What's my first step when I'm doing elimination? Make sure they're all lined up. Are these lined up? No? So what do we need to do? Let's call this equation number 1 and this equation number 2. Equation number 1 has the y where? In equation number 1 or 2? The y is with the x in equation number 2. Okay, in number 1, where is the y? By itself. So if I want 2 to look like number 1, what do I have to do? I have to get the y by itself, so I have to move the x. How do I move a negative x? By adding it, plus x. And what do I get here? Y equals... I could either write 2 plus x, but then is it in the right order? No, so how could I write it? X plus 2. Because it's addition, the order doesn't matter. So here's our new second equation. And I'm just going to rewrite our first equation. Y equals x minus 1. All right, now if I want to do elimination, what am I going to have to do? What am I going to have to do? Because are either of these going to cancel out right now? No, I need one of them to be negative. Which one do you want to make negative? Number 2. Okay, so number 2, if I make this number 2 negative, that becomes negative y. What happens here? Negative x and negative 2. All right, now what happens to my y's? They cancel out, and that gives me what? If I have nothing, what do I put? 0. What happens to my x's? They cancel out. All right, and then what happens with my negative 2, negative 1? Negative 3. What's 0 minus 3? Negative 3. Good. Is that true? Is 0 equal to negative 3? No? So what would we call this? No solution. All right, that would be a no solution. 0 is not equal to negative 3. What did you notice? What happened to both the variables? They both canceled out. In this case, both our variables canceled out, and we were left with this statement right here. That statement is not true. 0 is not the same as negative 3. Therefore, it is a no solution. Could you do that any other way? Could you do it by substituting, Brendan?
Yes.
Yes? What were you going to say before I said substituting? Substitution? Okay, so let's take a look at this again. Let's take a look at y equals x minus 1 and negative x, what was it? Negative x plus y equals 2. All right, again, what does substitution mean? You plug in. So in this case, in my first equation, I know that y is the same as what? What does y equal? X minus 1. That means wherever I see a y in my second equation, what could I write instead of writing y? X minus 1. So I'm going to write my second equation and write negative x plus, instead of y, I'm going to take that out. And what am I going to put in? X minus 1 equals 2. All right, what's negative x plus x? Nothing. Those go away, right? So that's 0 minus 1 equals 2. What's 0 minus 1? Negative 1. Is negative 1 equal to 2? So this would be a no solution. Does this look like more or less work than the elimination? Less. To me, it looks like less. So again, I know that substitution is definitely complicated, but in this case, substitution made a lot more sense because it happened really quickly. All right, our variables canceled out really quickly and we were done. So if you want to use elimination every time, you can. However, just know it's not always the most efficient way to do it, okay? Sometimes the most efficient way to do it might be graphing. In this case, I wouldn't do graphing because they weren't both in slope-intercept form. Brendan?
So,
Like when do you use which one?
when do you know to use which one?
Okay, so here's what I'll say. I use substitution when one of them already has a variable by itself. So in this case, this one had a variable by itself. I know that means it's going to be easy to plug in. I use elimination when both of my variables have coefficients. And I use graphing when they're both in y equals mx plus b. So that's like my little...
And also when you're substituting, how come it wasn't in parentheses?
Okay, I did not put it in parentheses because there was no coefficient, so I wasn't going to have to distribute anything. All right, good question. I should have done it just because I tell you guys always to use parentheses. Okay. All right, so again, if we graphed it, what would we find? That the lines are parallel. If they're parallel, that means there's no solution, because if they're parallel, that means they won't ever what? Touch, which means they can't cross. If they never touch, they never cross. Okay? All right. All reals means that you get to something where it says like 17 equals 17, or 0 equals 0, or 12 equals 12. The difference is that when you get to this statement, it's not false, it's true. All right? When it's true, that means it's all reals. So let's take a look at y equals 2x plus 1. And 2x minus y plus 1 equals 0. Okay, now, there's three different ways I could do this. I could graph, I could substitute or I can eliminate. What do you guys think I should do here? I think substitute. Does anyone know why substitute here? Guillermo? Uh-huh. Yeah. So one is in y equals mx plus b, the other is not. Then substituting works the best because here I can substitute, instead of writing y in my equation number 2, what could I write? 2x plus 1. So again, I can substitute that right in there. Okay, so then what does my new equation look like?
2x minus 2x plus 1.
Okay, why are those parentheses really important here?
Because then the 2x will be negative.
Yeah, so this becomes negative because it's got a negative right here. So my equation, when I distribute this negative, ends up as 2x minus 2x minus 1 plus 1 equals 0. Brendan?
And if you didn't use the parentheses, it would still be plus 1.
It would, if you didn't use the parentheses, yeah, you would make the mistake and probably leave that as a plus 1. Okay, what happens? 2x minus 2x is 0. Negative 1 plus 1 is, so this gives me 0 equals, which means the answer is all reals. Okay, so my variables disappeared, and I got a true statement. So it's all reals. Again, I know you guys, I know you want to think substitution is hard because intuitively it might not be the easiest. But again, I really think a lot of times substitution ends up being the simplest. You just have to spend a little bit of time practicing. I had 6 people come to office hours, and I feel like you did 3 problems and substitution became easy. Right, Guillermo? Right, Clarissa? You just do a couple of them, and I promise it becomes easy. I substitute more than anything else. Okay? Because elimination is great, but in elimination, if you have to multiply both of them by things, it gets really complicated. Substitution, I know it looks a little bit harder, but honestly, you're just plugging in. Okay? So like Guillermo said a minute ago, substitution makes sense when you have one of them y equals mx plus b, the other one not. Elimination makes sense when neither of them are y equals mx plus b, and graphing makes sense when both of them are y equals mx plus b. Okay, that was a lot, all right? But if you had graphed those, it would have looked like this, where the red line is on top of the blue line. They're exactly the same. That's an all reals. Diego?
I think I might know it faster.
Yeah, totally.
Okay, so
Go back or stay here?
stay here.
Okay. Yeah. Do you want the microphone?
It doesn't matter.
All right, I'm just going to hold it. You go ahead.
Okay, so if you see this y right here?
I do.
Okay, so if you just add this y on both sides, that makes both of them the same.
Oh, okay. All right, did you guys hear what Diego just said? So what Diego just said, don't erase that, that was good. All right. So what Diego just said is if you manipulate the red equation, you can see right away. So what he said is, okay, that becomes 2x plus 1 equals y. If you just move the y to the other side, what do you notice about these two equations? They're exactly the same. They're on different sides of the equal sign, but they're exactly the same. So right here, you could have stopped and done no work and known that they were going to be right on top of each other because they're exactly the same. Okay? So if you ever see something like that and make it happen really quickly, by all means. You don't have to prove to me that they're the same if they're the same equation. Okay. Mind blown. Great work. All right. So I want you to try these. Just do 2 of them. Just 2. All right. So with systems of equations, then, we talk about how to classify them. When we're classifying something, what does that mean? Like I say that your classification is freshman, so what does that mean? Your grade, okay. So if I were to classify a group of students, what would I do? Separate them into groups, right? So if I classified this group, I would put you all into freshmen, and then you would be one classification. How else could I classify this group of people in this room right now? I could do hair color, okay? I could put everybody with brown hair in one corner, with black hair in one corner. We would have a very empty blonde corner. There'd be nobody in it. We could have a red corner, and there'd be one person in it. Okay, so we could do classify by age, and that would make me feel really bad about myself because most of you guys would be in 2 groups, and then I'd be all old in the corner. Okay, how else could we classify ourselves in this group?
Eye color.
Height, you could do height, like people above 5'9", people lower than 5'9", then people that are really short, people that are above 6 foot. Okay, what's one more way we classify people? What's one more way? How else could we classify?
What sports they play.
Okay, so maybe like what sports you play, and then you could have a corner of people who don't play sports, people who play basketball, people who play football, so on. All right, so if we're classifying systems of equations, there are 3 ways we can classify them. We can classify them and say that they have one solution, all right, and that's when the lines cross at one spot. We can say that they have many solutions. That's when they're on top of each other. I know you can't really tell it here, but this is supposed to be 2 lines on top of each other. And then you can have no solutions, and that's when they're parallel lines. So the way that we talk about those is we classify them and say they're consistent and independent, consistent and dependent, or inconsistent. Okay, so consistent just means that there is a solution. If it's independent, there's just one. If it's dependent, there's many. And if it's inconsistent, there's none. I do not care about those words. Okay? I just want you to be able to tell me if there's one solution, no solutions, or all reals. That's all I care about. All right? I know that you guys could probably spend some time and memorize those words. I really just don't care. All right? I want you to just be able to explain to me either it's got no solutions, one solution, or that there's many solutions. If there's one solution, what should you do? Like if people wrote solution on the board, what did I make them do? Find out what the x, y is, okay? It doesn't really do you any good to tell me there's just one solution. Tell me what it is, all right? So again, I'm not worried about these words up here at the top. This is the part that I'm worried about, how many solutions it has. Okay, so if you were going to classify it then, we basically just did classify them. You just say it's no solution, all reals, or just one solution, okay? So then if I want to classify this one, what would I do? I want to classify this system, so what would I do? Okay, I've got to do something. So what can I do to the top one? All right, I'm going to distribute the top one, and it becomes y equals what? 2x minus 2. Okay, now I need to classify it further, so what am I going to do next? I can graph them. Why would I graph these? Why are these a great example of one that I should graph? Montrell? They're both in mx plus b form. So these are both in y equals mx plus b. So I'm going to draw a quick coordinate plane. Okay, now this top one, we'll call this one right here equation number 1. In equation number 1, what's my y-intercept? 1. So I put my first point here at positive 1. What's my slope? 1 over 1. So that means I go up 1 over 1, up 1 over 1. All right, so up 1 over 1, up 1 over 1. So there's my line. All right, I'm going to do the second one in red. This is number 2. Where's my y-intercept? Negative 2. So where does that start? Down here. And then what's my slope? 2 over, which means I go up 2 over 1, up 2 over 1, up 2 over 1. So I'm looking at this, and I want you guys to tell me, is this how many solutions? One solution. All right. Could you find it? Yes. Am I going to make you right now? No. All right. So we would classify this as one solution. How come it's not no solution? They touch. How come it's not all reals?
Because
they're 2 separate lines, right? So they're not all reals because they're not right on top of each other. Okay, for your exit ticket, I would like you to just do 1 and 3a. That's it. 1 and 3a.